Now, for the skin itself, just skin, has two regions, an epidermis and a dermis. Those are considered skin. The epidermis, again, epi meaning on, the word itself means like on skin. It's the top region. It's made up of epithelial tissue. Which kind of epithelial tissue? You had to learn it already. Which epithelial tissue is the top layer of your skin? The stratified squamous epithelial tissue. Underneath that, we have the dermis, and that's the thicker, the majority of your skin where you find all the cool stuff. You also find some of that dense, irregular, fibrous connective tissue in the dermis region. And then underneath the skin, so it's not actually skin, but it's the only place we can study it, is your hypodermis, and I'm like, which just means below skin. It's also sometimes called the superficial fascia or the subcutaneous layer. They all mean the same thing. Now, again, the hypodermis is not technically skin. It's just below the skin, and it holds the skin to the muscles. So it's not part of skin, but there's things that happen with the skin. Mostly what you find down there is that adipose tissue, your fat tissue, and that helps stick the skin to muscles. Do you guys not have this, however? I'll get it for you. They got a packet where they had it. I have no idea why. Sorry. I'll have it for you on Wednesday, Thursday. That's why your eyes are all flipping back and forth. You have it? Was it in order? After tissues? After tissues? We'll look in a little bit. That's the tissues. That's what you have to look at online. This is chapter 5. You have it? All right, epidermis, more about the top layer of the skin. Yes, you've already said it before. It is stratified squamous epithelial tissue, and I'm like, it has, again, lots and lots and lots of layers of cells, making it that stratified. The squamous means the top cells kind of look irregular. Now, it is keratinized. What is keratin? Yeah, it's that waxy protein, makes our skin waterproof. Now, in the epidermis, there are 5 distinct layers in the epidermis. It's all lots and lots of cells, but there are 5 distinct layers based on what the cells are doing, what they look like. It doesn't mean it's only 5 cells thick, but there's 5 layers of different types of cells in that epidermis. And I'm like, ones you had to learn in lab already, you had to learn the bottom one, stratum basal, and you had to learn the top one, stratum corneum. There's also a stratum spinosum, stratum granulosum, stratum lucidum, and a stratum corneum. Now, I have on here in the stratum lucidum, that is a layer that is only found in thick skin. Where do you think the thickest part of your skin is in the body? Soles of your feet and the palms of your hand. And I'm like, so only those parts on our body are you even going to have this stratum lucidum, sublayer. Everywhere else in the body, your epidermis has the basal, the spinosum, the granulosum, and the corneum. Now, some of the cells you find in these regions, and I'm like, I feel like I have a whole slide on them. I do, they're coming up. And I'm like, we find in the epidermis keratinocytes. What do they make? Keratin. Melanocytes. What do they make? Melanin. And then we haven't talked about them in lab yet. Well, the first one. And I'm like, we have dendritic cells, also known as Langerhans cells. Sounds cool. And I'm like, and tactile or Merkel cells. These really are for touch. Anytime you think about touching is tactile. Now, I've got a whole slide on cells coming up. But with those 5 layers, this is showing 4 of them, so this would not be thick skin. The stratum basalis at the bottom, the spinosum is up above, the stratum granulosum, and then the stratum corneum, which is the thickest. But there's some distinct differences in what the cells look like, what you find in each of these sublayers, which is why we don't just say, oh, they're all the same. No, those cells that we find in here, I knew I had a slide. And I'm like, the keratinocytes, you already know it, they make keratin. Most of the cells of the epidermis are the keratinocytes. They make lots and lots of keratin. They fill up the cells that are there. They make our skin nice and waterproof. Now, they are tightly connected to each other by what are known as desmosomes. These are just little junctions that hold cells together. So a desmosome is just a junction that holds two cells together. This is why what happens about a weekish after you get a sunburn? You peel one cell at a time. You know, they come off in the big layers. I like to do it. And I'm like, they come off in the big, huge sheets. And I'm like, that's desmosomes that are holding all of those skin cells together. And I'm like, so that they get shed in sheets. And I'm like, otherwise, even when you scratch your skin, you know, I'm like, it usually still isn't one cell at a time. They're usually stuck together with desmosomes. That doesn't mean you can't scratch them away and break those tight junctions, but they're held together by little tight junctions called desmosomes. Your melanocytes that make melanin, they are found in the deepest part of the epidermis. In which layer? The stratum basal. So you find these melanocytes, and yes, they make melanin. It's that dark pigment, and they package it into, just like, I would say, they're almost like vesicles, but they're not, you know, don't have a little plasma membrane. But they package them into little packages called melanosomes, almost like a region with melanin. Now, what the melanin does, it's like that dark pigment prevents UV radiation from penetrating into the DNA or affecting the DNA of the cells below it. So it kind of forms this nice protective dark shield from your UV radiation. Also in our epidermis, we have dendritic cells or Langerhans cells. These are macrophages. And I guess what macrophage means? You can go back to the first and be like, what's phage mean? Eating. What do you think macro means? Large. These are big eaters. And I'm like, so we find cells that are big eaters. And I'm like, these are ones that, yes, are trying to ingest anything that may get into our cell that, or into our skin that shouldn't be there. And other than the fact that they're like, oh my goodness, there's something in here, whether it's dust, debris, a splinter, whatever, they're trying to eat it and get rid of it. But they also, as they're realizing that something's foreign there and are trying to eat it and get rid of it, they also tell the immune system, like, there's something here that shouldn't be here. We probably need some reinforcements because there's probably going to be an infection that gets in with it. And then we have our tactile, our Merkel cells. These are our our little sensory receptors. And you have a lot more sensory receptors in your fingertips than in other parts of your body. But these are just little sensors. Now, we're going to look at these layers starting at the bottom and working our way up. So the stratum basal, the deepest epidermal layer. Occasionally I see it in certain books called the stratum germinativum. What's it mean to germinate something? We will have more of it. It means to grow. And I'm like, and so growth happens here. It's the basal layer, it's the bottom layer, but germinating means to grow. So things will grow. This is where you have lots of mitosis happening. Now, since it is the bottom layer, it is attached to the dermis below it, the main part of the skin. I wish I could write all over this. It's going to go onto the board behind it. But the basal layer, that stratum basal, is a single row of cells. It's not like, oh, 30 cells thick. It is one single layer of cells that are mitotically active, which means these are the ones at the very bottom that are undergoing mitosis. One cell becomes two, you know, and I'm like, and as they start to increase and make new cells that make their way to the surface. And I'm like, so these are the ones, just the ones at the bottom are the ones undergoing mitosis. That's it. They're the only ones that undergo mitosis. And that one cell will produce two daughter cells to go from the very bottom layer, the stratum basal, all the way to the surface of the skin, and you can scratch it off. It takes about a month, 25 to 45 days, give or take. It takes about a month to go from the very bottom layer to the very top layer. as they go up, they were born in the bottom layer, brand new, they were all alive. As they go towards the surface, all the way to that stratum corneum, they do die. They will die. But they don't all move to the surface, or we never have skin. You always have at least one cell that stays down there. Just sitting there is like, all right, I just need to stay here and make new cells. My whole job is just to produce new cells. And it's also in this layer where we find melanocytes. About 10 to 25% of the cells in your stratum basal layer are all melanocytes making melanin. Now, that in itself is a range, 10 to 25%. Everyone in the world has approximately the same number of melanocytes. And everyone's like, whatever, everyone's a different skin color. And I'm like, everyone still has approximately the same number of melanocytes. It's just the amount and the specific color of melanin that varies between people. And I'm like, so everyone has about the same. It's just what color is the melanin. Sometimes it's darker in some people than others. And how much is made, that varies. Sometimes those melanocytes are very active. As we go up, the stratum basal is the very bottom single layer. As we go up, we get into our stratum spinosum. It's several layers thick. We got several cell layers thick. The part that makes why they call it spinosum, because what do you think when you think of the word spinosum? They're spiny. And I'm like, they do. And I'm like, if I drew here's my weird cell, they do almost look like they have like tiny little spikes sticking out. Some pictures are better than others. I think I've got another picture coming up where it looks like it. And I'm like, but they have like a little web-like system that allows like one cell to attach to another cell, using these little spikes, and they all attach to each other. They're also attached together at desmosomes, holding them together, as well as these spiny little spikes. Now, because they're right above that stratum basal where you had all those melanocytes making all that melanin, you're going to have lots of melanosomes. And I'm like, it's like little compact areas where you just have lots of melanin. So you got lots of melanin in your stratum spinosum. It was made in the bottom layer. You're going to see lots of it in the layer right up above it. You're also going to have lots of dendritic cells as well. Again, we don't want anything to get past this outer layer and down into the dermis. So you've got lots of dendritic cells that are trying to eat up things and send messages to the immune system. Above that, we have our stratum granulosum. They look kind of grainy, hence the granulosum. It's thin, 4 to 6 cell layers thick. And it's in this region that the cells are dying. So the cells start to squish and flatten even more. The nuclei dies and goes away. Other organelles die, they go away. And you get what's known as keratinization to start. This means now the cells that are losing all their organelles are filling with keratin. That's what keratinization is. The cells are filling with keratin. Now, because all of these cells, they are dying and they're filling with keratin, there are no nutrients going to anything above it. So if the cells above it haven't died, they will. And I'm like, because these cells have died. Nutrients always have to go from bottom up. We can't put nutrients into our skin. It annoys me when I hear advertisements like, here, put on this lotion. It's got all these minerals and vitamins in it. Great. It's not going to get into your body. And I'm like, minerals go from up. So once we've killed the cells off in this region, in your stratum granulosum, nothing's getting above it. So if the cells above it haven't died, they will. There's no blood vessels, there's no nutrients, nothing coming. Above the stratum granulosum, this is looking at thick skin, normal thin skin. There's this really, really skinny layer that we only find palms of our hands, soles of our feet, where we have that thick skin. It's just a really thin layer of flat, dead keratinocytes. That's all you find there. Just some cells that make keratin. They're just hanging out there. ready to get sloughed off as you scratch. And then the top layer is known as the stratum corneum. And sometimes you're like, what? It's called a horny layer? Yeah, it is. And I'm like, cornea means horn. And I'm like, so the same type of material that makes a horn on an animal, I'm like a rhinoceros, it makes it nice and hard. This is kind of like that hard, dead tissue. And so we have 20 to 30 rows, which is why I can scrape away and not do damage. 20 to 30 rows thick of dead, flat cells. They don't have a nucleus. They don't have any organelles anymore. They are just filled with keratin. So sometimes we don't even call them cells. We call them keratinized membranous sacs. There's really nothing cell about them anymore. They were a cell. Not anymore. Now, they make up, because there's 20 to 30 rows, about 3/4 of the epidermis. And just because they're dead doesn't mean they don't do anything. Their biggest thing is protection. They protect the cells underneath from anything getting in, any type of damage. They're protecting from abrasion. They're protecting from water loss. They make a nice barrier for water loss. Water doesn't get in, water doesn't get out. I'm like, they're constantly reporting different, getting chemicals spilled on you throughout the day. If you clean anything, you've got cleaners on you. And I'm like, we've got, bacteria, whatever else that might be on your skin. I'm like, they were an awesome little, that epidermis is a fortress. That stratum corneum, those dead layers, is having a nice thick fortress all around our body. Now, as you go from the bottom to the top, from the stratum basal to the stratum corneum, yes, the cells die. Like I said before, and I'm like, is you have apoptosis. The cells kill themselves off. We don't want them alive at the surface. So everything has to go away. No nucleus, no organelles. The plasma membrane will thicken, and it will fill with keratin. But as it takes about a month to go from that bottom layer to the top layer, well, what happens once it's at the top layer? It gets sloughed off as dandruff, as dander. It's known as the process of these dead cells coming off of your skin. It's called it's a horrible word, desquamatization. I can't say that fast. And we shed about 50,000 cells every minute. So you think about how long we've been in class today already. That's a lot of dead skin cells that are just all over. They make up the majority of dust in your house. So if you're wondering, you're like, the dust. What is all this dust that shows up? Skin. Now, what rooms are the dustiest rooms in your house? Living room's a big one? There's 2 other really big ones. Bathroom. And your bedroom. These are where you spend a large amount of time. And you're like, I don't spend a lot of time in the bathroom. But think of what you do in the bathroom. Every time you shower and you towel dry, you are scratching off dead skin cells. And I'm like, same thing. When you were in bed and you roll around in bed all night long, dead skin cells all over your bed. That's why your old mattresses weigh more than new ones. And I'm like, yeah, lots of dead skin cells and some dust mites and all that stuff else that's in there too. Yay! Isn't it? And I'm like, but we shed lots and lots of skin cells every day, every minute, and they all have to end up somewhere. Makes you want to go wash your sheets and get a new mattress. Now, here was my picture that I knew. I'm like, for that spinosum, that I like this picture. And I'm like, this is looking at your 4 basic layers in your thin skin. You have your stratum basal, 1 cell thick. You find melanocytes that make melanin in it. Here you can find some of those tactile, those sensory Merkel cells. As you go up, you get in that stratum spinosum. And these little dark dots, that's the spiky parts. So I like this picture. You've got a dendritic cell there. That's, again, going to initiate the immune system and then try to get anything that got in that far and eat it up. We've got our stratum granulosum. They're kind of grainy. Again, the cells are dying at this point. And so you had dark nuclei, and they start to go away. Nothing has a nucleus or organelles by the time you get into that stratum corneum layer. The cells are dead and just filled with keratin. There's your epidermis. Into the dermis, the main part of your skin. So this is your strong, flexible tissue. It is a connective tissue, connects every part of the body. We find lots of different types of cells. There's fibroblasts. These are building cells that build fibers. Macrophages, big eaters. Occasionally you find some mast cells, we'll get into it, part of the immune system, and some white blood cells there. We also have lots of nerve fibers, blood vessels, and lymphatic vessels. These are things that were not found in the epidermis. We also have hair follicles. This is where, the cells, they originate. And I'm like, you have your oil glands, you have your sweat glands, and it is big enough that we do divide that dermis into two different kind of sublayers, our papillary layer and our reticular layer. So this is showing, here's the dermis. The papillary layer is this tiny little part up there. And then the reticular layer is the major. And you're like, why would you even divide it if the papillary layer is only that, that tiny little region? But there's stuff that happens there, so we care about it. And I'm like, here's our papillary layer. Now, and I'm like, up at that very, very top portion is where you're going to find some areolar connective tissue. So our papillary layer, here's, here's we're getting into our epidermis. And I'm like, and underneath it, we have this top thin papillary layer. You have your areolar or loose connective tissue there. There's lots of blood vessels that are feeding those mitotic cells in the epidermis. In that loose areolar connective tissue, because it's loose, there's space in there. It allows phagocytes, eating cells, like a macrophage. And I'm like, to go around and patrol to see if anything got in that shouldn't. If there's any bacteria that got all the way in, you got a sliver that penetrated all the way in, and I'm like, they're just patrolling through this top layer. Also at the top, and I'm like, we have these dermal papilla. Now, the word papilla, if you go back and you're like, and I'm like, what papilla means? It means a nipple-shaped mound. It means it's just something that goes up and comes back down. And I'm like, and in the papillary layer, it's part of the word, you have all these rises and falls. And I'm like, in this dermal papilla. Now, what that does, and you're like, oh, who cares? It rises and falls. And I'm like, it forms with all these ups and downs and ups and downs. It forms friction ridges or epidermal ridges. That some of these rise and falls continue with the epidermis, and the epidermis rises and falls with it. Now, where do you think we have the best, based on what it does? Well, it says it on there. Where do we have the best, where do we have the most friction ridges? Our fingertips. If you look at your fingertips and you're like, oh, there's a reason why you have fingerprints. Those are dermal ridges. That was the dermis going up and down. The dermal papilla went up and down. The epidermis followed it. And now you have fingerprints that go all around. They give us better gripping ability, because I'm like, we can grip with our fingers by having all these little ridges. We give a better sense of touch by having these ridges. You can feel things bumpy, softer, and we give our fingerprints. So this is looking at some of these ridges. These ridges originated down in the dermis, and then the epidermis just continued with it. Now, what do you see all over your fingertips? It's labeled. We have sweat glands. This is why I'm like, your palms, and your fingertips are some of the sweatiest parts in your body. Now, and I'm like, one thing you do not have on your fingertips, you do not have any hair follicles. It would look funny if you had hair all over your fingertips. Now, what is attached to your hair follicle that also secretes something? Those oil glands, those sebaceous glands. We don't have hair follicles. We do not have sebaceous glands on our fingertips. And everyone's like, but my fingertips are oily all the time. Your fingertips themselves aren't making the oil. It's the fact you're touching other parts of your body. And I'm like, that they become oily. Everyone's like, no, it's not your fingers. It's just don't touch things. And I'm like, and you'll be fine. And I'm like, but you do make a lot of sweat. So when people leave fingerprints on things, unless they've been touching dirty things, they're leaving like little sweat prints with some skin cells behind. Now, the bottom layer, the reticular layer, that makes up the majority of the dermis, and yes, this is where all the cool stuff is. It's made up of dense, fibrous, irregular connective tissue. We looked at this in lab. They all go in weird little directions. It's the irregular part. And by having all of this connective, these fibers, irregular and everything else, and I'm like, it allows our skin to stretch and hopefully recoil, which means if I pull on my skin, it goes back and it doesn't stay like that. You know, when your parents always say, oh, if you make that face, it stays like that. It shouldn't. And I'm like, oh, you got some skin problems. And I'm like, your skin, because of those fibers, when you stretch it, should recoil as well. Now, all of those fibers, the main ones that allows that recoiling are your collagen fibers. And I'm like, that's the biggest recoil. The reason why skin starts to sag and wrinkle as you get older is you start to lose collagen. And so when it stretches, it doesn't bounce back anymore. It just stays stretched. Yeah, it's great. And I'm like, but what the cool thing is, the collagen fibers like to run together. Yes, a lot of your dermis is irregular, but a lot of the collagen fibers like to run in the same direction. And they like to run parallel to certain parts of the skin surface. Now, where the collagen is running in lines, we call these, you know, when the collagen is running together, we call them cleavage lines. You can't see it on your skin, but we know that the collagen fibers are running together, all together, underneath the skin. It's important for surgeons to know where the collagen is. It makes surgeries and cuts a whole lot easier, especially for the healing process. Now, and I'm like, I've got a picture, and I'm like, this is generally the direction of where all of your collagen cleavage lines run. And so your collagen fibers in your skin run in these particular directions. And so if you've ever had a surgery, and I'm like, the doctors tried to make a cut right along where the collagen lines go. Now, that doesn't mean sometimes where it is they can't. And I'm like, but they try. If you have knee surgery, they try to go across. They have to open it all the way up. Yes, they're going to have to make a cut that way too. But if they can cut with the collagen fiber, it makes healing a lot easier. And I'm like, you have less scarring. The tissue itself will heal. I'm like, because if your collagen fibers run up and down and you just slice them in half, it's going to take a lot longer for them to heal. If you can slice right along with them, they'll just seal right back up together. So surgeons do take into consideration what's under your skin when they make certain cuts. We're going to end right there because I don't want to get into pigments yet.